So I've got two questions on this in this video, and I'm just going to show you my solutions to both. So Great Amusement Parks has been raising its ticket price every year as shown in the table at right. Describe how the ticket prices are growing. Well, I think this is a little weak, but and I wouldn't put much stock in being able to predict future prices based on this pattern. But I can see that from year 0 to 1 it increased by $5, and from year 1 to year 2 it increased by 550, and then the next year it went up by 605. So I'm kind of seeing this not a real clear pattern, but if I go one more level out, the increase in the increase is 50 cents, 55 cents, and then if I project out, it could be 60, 65, 70. But that's pretty much just wild speculation on my part. However, if I follow this pattern, I suppose next, instead of increasing by 605, I'm going to increase by 60 cents more than that, so 665. And then the next year out, instead of increasing by 60 cents, instead of increasing by 665, I'm going to increase by 65 cents more than that, so 730, and then 70 cents more than that, so I'm going to increase by $8 in the last year. So year 6, $88.50, but again, I'm not exactly sure. So my prediction is by year 6, $88.50, but maybe I'm reading this wrong, but that's basically all I could see with that. On number 7, winning times for various swimmers at Smallville High School were compared to the height of the swimmers. The residual plots are shown at right. So one of the things, well, first of all, it says sketch the original scatter plot, the original scatter plot may have looked like. So there's the residual plot, and below is kind of a rough, what I think the residual plot may have looked like. Now, I could have gone either way with this. I could have said that there was a positive relationship, as the taller you got, the faster you were. But either way would work. The important thing is that I'm showing that my data point values are getting clustered closer and closer to my model as the swimmers get taller. So for some reason, as I have a taller swimmer, the model is more accurately predicting their swim times than the swimmers that are shorter. So you can see, up in this zone, you see up in here that there's a lot more scatter for the shorter swimmers. Some of them are faster than the model, some are slower than the model. No real pattern there, but they're kind of equally above and below. The residuals are above and below. But as I come out, and I'm looking at the taller models, you'll notice that it's closer and closer and closer to what the model predicts. So that if that line was the least squared regression line. So it says, what does the residual plot tell you about predictions made about swimmers that are shorter compared to predictions made about taller swimmers? So what I clearly see based on the residual plot is that the model appears to be more accurate with taller swimmers. The residuals became much smaller as the height of the swimmer increases, or the height of a particular swimmer. Well, as the swimmer miraculously grows taller while they're swimming? No, just as the height of swimmers increases, the model seems to be more accurate.